Everyone, my name is Chris Winter and I'm the CEO of Reach. Today I wanted to show you an example of a multi-sig wallet. So multi-sig stands for multi-signature. It is used when you want to have more than one participant sign off on a transaction. This type of functionality isn't really new. You've seen it in safe deposit boxes that have two different locks that need both to be unlocked before you can open them. You've seen it on your latest Bond movie or any type of war movie where there's a nuclear missile that needs to be launched and you need two different passcodes to launch. In blockchain, a multi-sig can be used for many different things. Today, I'm going to show you how it can work for a parent paying for the bills of a child that has recently left for college. So I'm going to show you this application written in Reach, and we're going to launch it both on Algorand and Ethereum network. So now the output of what I show you today is actually over 1,400 lines of code that you'd have to otherwise have written manually by hand, and most likely probably made a few mistakes along the way. But however, with Reach, it's only going to be 40 lines of code. And not only that, but it's going to be mathematically guaranteed to not have any loopholes that would lose all of your money or all of your your children's potential assets. So before I jump into the code, though, I'd like to ask you to like and subscribe to the video. What this allows us to do is really kind of help us get the word out to other YouTube patrons. Also, it allows you to get notified whenever we launch a new video. So with all of that, I'm going to go ahead and jump right into the code. Just over, and there we go. All right. So this is the start of the Reach application. As you can see, the start common. Just usually say we'd like to wait for 10 blocks for anything to happen. This can be changed during timeouts. But first we declare the child, which they will request a payment to be made. The parent sets the total allowance and decides if the product will be paid or not, or if the bill will be paid or not. First, the child creates the contract and submits it. The parent attaches to that contract and determines how much allowance that the child will have. It publishes that allowance and it pays that allowance out of the parent's wallet. Here, all we're doing is really just tracking the times that the parent says yes or no, but this isn't really needed for the contract. This is more for just analytics purposes. And then we start the actual application. This is going to be a loop because the child is going to ask for multiple different types of payments, not just one, until the money is all gone at least. And that's why here the balance is not equal to zero. And so this starts. The child requests a payment to be made and publishes it to the blockchain. The parent then decides if they're going to approve it or not. And if it's approved, it actually pays out. If it's not approved, it doesn't do anything, and it loops back and waits for the child to ask for more money. And like I said, this happens until all of the money is gone. Over on this side, this is the interface. This isn't part of the Reach program, but this is the way that we're just running this Reach application. This would be a web interface or server or anything that you would want, but all we're doing here is just automating this and automating the test so I can actually show you something running. But pretty much what this does is it starts the contract with 64 bits of currency, and the parent randomly says yes or no until all of the money's gone. So let's go ahead and just start this application up. Okay, let me actually clear this out and start this up. As you can see here, we're building this application. I think it actually already ran once, but building the application, and let me make this a little bit bigger so you can see. Here, parent starts with a deposit of 64, and the child asks for 32 out of 64. Parent says, no way, don't pay for that. The child asks for 32 again. Parent says, nope. The child asks for 32 again, and the parent finally says yes. So you can see here that balance actually goes down, asks for 16 until it gets down to the very bottom and it's complete. Now, that isn't the entire application. This is my script here ran both on Algorand and Ethereum. So it works for both chains. Didn't change any code whatsoever. And that's that. I think this is gonna be a pretty short video. I mean, it's a pretty short and sweet application. And this really shows the power of reach. Writing this application out and making sure that it's correct would normally take you weeks, if not an entire month, to actually do correctly, or 1,400 lines of code, which is pretty ridiculous when you're building an application for both Ethereum and Algorand. And here, we did it in just under 40 lines of code, which you could probably break out in under an hour. So once again, thank you so much. If you haven't subscribed, please do. So I usually do these videos once a week to give you an idea of what types of things that you can build. And until next week, thank you so much.